Let's do section 11.3, page 565, exercise 47, which reads, find the area of the region described. And in exercise 47, the region described is inside one loop of the lemniscate, r squared equals 4 cosine 2 theta. So the first thing that we do in a situation like this is to graph. And I usually like to graph from theta equals 0 to theta equals 2 pi just to see what my graph is going to look like. And when I do that, I end up with a curve that kind of looks like this, except it would be a little more symmetric. And my viewing window is -3 to +3 in x and -2 to +2 in y. And like I said, this is theta goes from 0 to 2 pi. But I only want one loop. So I need to do some experimenting with what I would let theta be equal to. And for instance, if I let theta go from 0 to pi, I end up with something like this. And a little more experimenting shows me that if I only want one loop, I want to have -pi/4 is less than theta, less than or equal to theta, which is less than or equal to +pi/4. So this is going to be my interval for theta. Now, the formula that we use to find area is A is equal to the integral from alpha to beta, those are two angles, times 1/2 r squared d theta. So for this problem, I'm going to substitute in, and my limits of integration are going to be -pi/4 to +pi/4. I've got 1/2, and then I'm going to substitute in for r squared, which is going to be 4 cosine 2 theta d theta. Of course, I can cancel this 1/2 and part of this 4 and end up with a 2. So this will give me 2 times the integral from -pi/4 to +pi/4 of cosine 2 theta d theta. And just to make things straightforward, I'm going to do a u substitution. So I'm going to let u be equal to 2 theta. So du will be 2 d theta, or d theta will be du over 2. So this is going to give me 2 times the integral. I'm just going to leave my limits of integration the way they are, and I'll substitute back in for u in the end. And that's going to be cosine u du over 2. And those 2's are going to cancel. And of course, we know that the integral of cosine u du is going to be sine u. And I have limits of integration which correspond to theta, but that's okay because the next thing we're going to do is to substitute back in for u. So this is going to be sine 2 theta evaluated from -pi/4 to pi/4. And when we substitute in, we will have sine 2 times pi/4 minus the sine of 2 times -pi/4. So we're going to cancel this 2 with part of that 4. So that's going to give us the sine of pi/2, which is 1, minus, and I can do something similar here. That 2 is going to cancel with part of that 4. And now I have the sine of -pi/2, which will be -1. And 1 minus -1 gives me